Hello everyone, welcome back to Civil Learning Online YouTube channel, and let's continue our lecture on Laplace transformation. This is going to be third lecture on Laplace transformation, and I hope you have watched lecture 1 and lecture 2. If not, link is in the description. You can watch them because those lectures are important to continue with lecture 3, because in those lectures I have discussed with some important formula about Laplace transformation. So in this lecture I am going to discuss few new things, that first shifting theorem and how to do Laplace transformation when a function is multiplied with t. So without any further delay, let's get started. So first let us know what is first shifting theorem. So I am going to write down here first shifting theorem. It states that when a function is multiplied by e to the power at, then it corresponds to shifting of the argument of its transform by a units. For example, what does this definition says? For example, if we are asked to find the Laplace transformation of t and it is multiplied with e to the power at, then what we should do is we know that Laplace transformation of t is going to be t to the power 1, means 1 upon s to the power. Laplace transformation of t is going to be 1 factorial, means 1 upon s to the power 1 plus 1 2. So what it says, when a function function means here it is t is multiplied with e to the power, then we have to shift the argument by a unit. It is multiplied by e to the power at, means we have to shift this argument by a unit. How we can shift? We simply need to add or subtract a unit. If it is positive, then we need to subtract. If it were negative, then we need to add. So we will have here s minus a to the power 2. This will be more clear because I have picked out some numerical problem which I am going to solve in this video to clarify this concept. So here these two examples are based upon this concept of first shifting theorem. So our first example is question number 1, e to the power minus 3t times 2 cos 5t minus 3 sin 5t. So let's begin the solution of this numerical. So Laplace transformation of e to the power minus 3t, let me rewrite it. Laplace transformation of e to the power minus 3t times 2 cos 5t minus 3 sin 5t will be equals to Laplace transformation of, we need to just multiply both the terms by e to the power 3t, 2 times e to the power minus 3t times cos 5t, close the bracket, minus Laplace transformation of e to the power minus 3t times 3 sin 5t. Now what we will do here, see, if you remember the formula, what is the Laplace transformation of? Laplace transformation of cos at was s upon s square plus a square, and a represents the constant which is used with t. So here we have 5, means Laplace transformation of cos, this is I'm just doing this to make you understand as a rough. So we have 5t, so we will have here s upon s square plus 25. And if we apply the first shifting theorem, that it says that when a given function is multiplied with e to the power at, then we have to shift the argument by a, and here we have a is -3. So what our answer is going to be, see here, this is 2 is constant, so bring this outside of the bracket, and Laplace transformation of e to the power -3t times cos 5t is going to be s, and here it is -3, so we will add here plus 3 divide by s square, means s plus 3 square plus 25. Nothing, this is different, just we are shifting the value which we got after applying the Laplace transformation in a given function. Function was cos 5t, which was multiplied with e to the power -3t, so we have shifted it with that value, that much value only. So we have here 3 times sin 5t is going to be a. Formula for Laplace transformation of sin 5t will be a, means 5, let it be at, so that you will get the formula also. Sin 80 Laplace transformation is a upon s square plus a square. So we will have here Laplace transformation of sin 5t will be 5 upon s square plus 25. So we will have here a means 5, and here we have -3t, so we have to shift the argument, so s plus 3 square plus 25. Now do the final calculation. At the denominator are same, so we need to do the addition or subtraction. Here both it is negative, so it will get subtracted, and and this whole will be multiplied by 2. So we will have here denominator is going to be s plus 3 whole square plus 25, and here we will have 2s plus 6 minus 3 times 5 is 15. So our final answer is going to be 2s minus 9 upon s plus 3 square plus 25, and this is our final answer. Let's look for another numerical now. So here comes question number 2, and our question number 2 is e to the power minus 2t times sine square 3t. And I have told you that whenever we are encountered with power of trigonometric function, then we need to convert the trigonometric function, we have to remove the power, and for removing the power I have already provided you the formula, and that was sine square theta equals to 1 minus cos 2 theta upon 2. So we are going to use this formula. In place of theta we will put 3t, so we will have here sine square 3t will be equals to 1 minus cos, in place of theta we have 3t, so 3 is multiplied with 2, we get 6t upon 2. So we will have here Laplace transformation of e to the power minus 2t times sine square 3t is equal to Laplace transformation of e to the power minus 2t times sine square, in place of sine square 3t we will put 1 upon 2 times 1 minus cos 6t. Now what we will do here, see here what we will do, we will bring this 1 by 2 on one side, and we will multiply both the terms with e to the power 2t. So we will have here Laplace transformation of e to the power minus 2t minus 1 by 2 times Laplace transformation of cos 6t. How this came? What I did, I multiplied both the terms with e to the power minus 2t by 2. E to the power minus 2t by 2, here it is 1, so and 1 by 2 is constant, so I have bring it out of the box, and here it is cos 60 is also multiplied by e to the power minus 2t by 2. We need to multiply this also, sorry, e to the power minus 2t, e to the power minus 2, this term is also multiplied with e to the power minus 2t by 2, and this 1 is also multiplied with e to the power minus 2t by 2. So this is what we will get. Now use the formula. We have e to the power minus 2t by 2 formula is 1 upon 2 times 1 by s plus 2 minus 1 upon 2 times cos 60 formula. Now cos 60 is going to be s upon s square plus a square, and here a is 6, so 6 square means 36. So we will have here 1 upon 2 times s, and so we will apply the shifting formula for shifting theorem, that is minus 2. So here it is minus 2, we will write it as s plus 2 upon s plus 2 whole square plus 36. Now do the final solution. Now we can take 1 by 2 common from here, so we will have here 1 upon s plus 2 minus s plus 2 upon s square plus 4s, just open up a plus b whole square, a square plus 2ab plus b square, 36. 4 plus 36 is 40. Now we need to take the LCM of denominator, so we will have here 1 upon 2, and we on taking the LCM of denominator we will have here s plus 2 upon s square plus 4s plus 40. Now we have taken this is the LCM of these both terms. 4 plus 36 is 40, 4s and s square, and I already told you that LCM of two different terms is going to be multiple of both terms. So this is what we have got. Now we need to divide the LCM by this term. The remaining will be s square plus 4s plus 40, and on multiplying this term with 1 we will get is as it is. So and here this is minus sign, s plus 2 times we need to divide this by this, so remaining is s plus 2, so s plus 2 times s plus 2. What we need to do is we have to multiply the numerator with what we got after dividing the LCM with the denominator. What I said, we have divided the LCM with this term, and with remaining will be s plus 2, so s plus 2 will get multiplied with the numerator. Numerator was s plus 2, here the numerator was 1, so the result would be as it is, so I have just written it as it is. So we will have here 1 upon 2 times s square. Let me write down the numerator for denominator first. So we have s plus 2 s square plus 4s plus 40, s square plus 4s plus 40 minus s square, and s plus 2 whole square is minus 4s minus 4. This minus sign will change the sign. S plus 2 whole square formula is s square plus 4s plus 4, so s square plus 4s plus 4, so minus sign will change, the minus will change the sign, so minus minus minus. Now got the opposite terms sign, so we will have here 40 minus 4 is 36 divided by 2, 36 divided by 2 will be 18 by s plus 2 times s square plus 4s plus 40, and this is our final answer. Let's move toward the solution of question number 3, which is different from the what we have done in these two problem, and that is about when a given function is multiplied with t. How to do that? Let's learn that now. So here I am going to solve 3 questions of the form multiplication by t times. So here is third question of this lecture, that is t times sine hyperbolic at. So when we have multiplication by t, I am going to write here solution. We have Laplace transformation of sine hyperbolic at. Sine hyperbolic at Laplace transformation is a upon s square minus a square, and when it is multiplied with t, so I am going to write one more line here, by using Laplace transformation theorem, Laplace transformation of t times sine hyperbolic at will be equals to minus 1 to the power, if t has power 1 then we will put here 1, if t has power 2 then we will put here 2, 3 then 3, 4 then 4. So here it is t has power 1, so I am going to put here 1 times derivative of, with respect to s, we will take derivative when a given function is multiplied with t. The theorem is this, we have to solve by using this theorem, like we have to multiply it by minus 1 to the power n, and n is the power that the t carries in the function, okay, and we have to do derivative that much time. If power 1, then we have to find the derivative once of which term, sine hyperbolic at of the function which are multiplied with t, we have to find the derivative of that function. So here we have to find the derivative of this function, a upon s square minus a square. Now here how we can find the derivative of this function, see. Now let us consider we have to take the derivative of u by v form, division form. So we have a formula, derivative of u upon v with respect to x equals to, derivative of u by v equals to v times du upon dx minus u times dv upon dx by v square. So this upper portion is u, so we have to find the derivative, so use it accordingly. So s square minus a square, this is our v, times du, u is constant, derivative of constant is equal to 0, so 0 minus u times means a times derivative of v, derivative of s square minus a square, s square minus a square will be given by, with respect to x we are calculating derivative with respect to s, so it will get splitted, ds square upon ds minus dA square upon ds, okay. So derivative of s square means derivative of x to the power n, derivative of x to the power n is n times x to the power n minus 1, so derivative of s square means 2 times s to the power 2 minus 1 is 1, so derivative of s square will be 2s minus derivative of a square, a is constant, so this is going to be 0. So what we will get here, derivative of s square minus a square according to dv by ds, we are calculating the derivative of s square minus a square with respect to s, so it will have 2s here, just forget this is a formula, we have calculated derivative of s square minus a square with respect to s here, so on doing so we have got 2s, so 2s and times a divide by v square, and our v is s square minus a square whole square, okay. So write it down here, so minus 1 to the power 1 is minus 1 times, and after doing the derivative we will get here minus 2a s upon s square minus a square whole square. So on multiplying both we will get 2a s upon s square minus a square whole square, derivative on finding derivative in the form u by v. I hope you understood this step. We have, see here, let me explain this once again. We had formula for finding derivative u by v, this is u and this is v, so finding derivative v times du upon dx, v is s square minus a square times derivative of a, this is actually derivative of a with respect to s, and a is constant, so derivative constant is 0, okay. Now here we have here we have u times d by dx, and u is a, so a times, this is how we got 2s is derivative of s square minus a square by ds, and how we've calculated the derivative of s square minus a square ds, this is here. I hope you understood this step. Now this was for question number 3. Now let's move to question number 4. If you guys have any kind of confusion, then you can write me at civillearningon@gmail.com, and I will provide the email address in the description also. So our question number 4 is t times e to the power minus t sine t. Now again we will write here solution, and we will write we have what we have? Laplace transformation of e to the power minus t sin t will be a is our minus 1. So we have Laplace transformation of sin at is a upon s square plus a square, and in place of a we have 1 here. Due to this e to the power minus t, we have to shift the argument, so we will have here a means 1 upon s, and here it is minus, so s plus 1 square plus a square is 1, so 1. So on solving this, we will get 1 upon s square plus 2s plus 2, because s plus 1 a plus b whole square is a square plus 2ab plus b square is 1 square, so 1, and this 1 plus 1 will get 2. Now we have to find the Laplace transformation, so I am going to write here by using Laplace transformation theorem. So by using Laplace transformation theorem, we will have here Laplace transformation of t times e to the power minus t times sin t will be equals to, so again we have here t to the power 1, means we have to write here minus 1 to the power 1 times we have to find the derivative once of what, this term 1 upon s square plus 2s plus 2. So how we are going to find the derivative of this term? See here. So we have to find the derivative of 1 upon s square plus 2s plus 2. We can rewrite it as derivative of with respect to s square plus 2s plus 2 to the power minus 1, because it is in division, so it can be written as minus 1. Now what happens? We need to apply the chain rule here. So ds square plus 2s plus 2 to the power minus 1 upon ds square plus 2s plus 2 times ds square plus 2s plus 2 upon ds. It gets separated. This is what chain rule says. Suppose we are asked to find the derivative of t square with respect to x, then what happens? According to derivative chain rule, we have to find its derivative in this form. We have to divide this by, if it is power, then we have to find the derivative removing the power, and then dt upon dx. That is what I have done here. It is in power minus 1, so I have just find its derivative with respect to the same term but removing power, and then again we have to find the derivative. Why we can do this? See here, these two gets cancelled out, then what with the remaining is equal to what we are doing, so we can apply this chain rule here. So again, now derivative of x to the power n with respect to x is n times x to the power n minus 1, and here in place of n we have minus 1, so minus 1 times s square plus 2s plus 2 to the power minus 1 will get minus 2 times derivative of s square plus 2s plus 2 with respect to s will get splitted into ds square upon ds plus 2 times ds upon ds plus 2 times derivative of 2 upon ds, and derivative constant is 0, so this term will get 0, and derivative of ds by dx, we know that dx upon dx equals to 1, so this is what we will get, 2s plus 2, this will get times 1. So here we will have 2s plus 2, and on resolving this we will get here minus, this is minus 1, so minus 2s plus 2 upon this, we have to, this is in minus, so we can rewrite it as a square, so s square plus 2s plus 2 whole square. Due to minus I have just brought it in division form. So here we will have here minus 1 will get multiplied with minus 2s plus 2, we can take 2 common, so 2 times s plus 1 by s square plus 2s plus 2, and a minus and minus will get multiplied, so it becomes plus. So we will have here 2 times s plus 1 upon s square plus 2s plus 2, and this is our final answer. Now let's move to question number 5. So our question number 5 is to find the Laplace transformation of t square times e to the power minus t sin t. Now we know that solution Laplace transformation of, we have Laplace transformation of e to the power minus t sin t will be sin t Laplace transformation is a 1 upon s square plus 1, and when it is multiplied with e to the power minus t, then we have to shift the argument, that is 1 upon s, and here it is minus, so plus 1 square plus 1, and solving this we will get 1 upon s square plus 2s plus 2. So here we will have 1 upon s square plus 2s plus 2. Now here we have t square, means we have to find the derivative twice. So using Laplace transformation theorem, what we will have, Laplace transformation of t square times e to the power minus t times sin t will be equals to t square times e to the power minus t sin t. So we will have here minus 1 square times d upon d square and ds square. We have to find derivative twice of 1 upon s square plus 2s plus 2. Now what it says, we have to find twice derivative of s square plus 2s plus 2 to the power minus 1. So on finding derivative once, what we got, on finding its derivative once, we got this minus 2s plus 2 upon s square plus 2s plus 2 whole square, and this is in the form u by v. So I am going to use this rule now, derivative rule. We have to find this its derivative. We have d square upon ds, means we have to find its derivative twice. On finding derivative one time, we got this. Okay, this is similar to what we did in the previous example. Now we have to find its derivative again. This d square by ds square double derivative is double derivative of this term. So on doing first derivative, we got this. Now again we will do the derivative of what we got, minus 2 times s plus 1 upon s square plus 2s plus 2 whole square. And again now we will apply the chain rule again, division rule, that is derivative of u upon v equals to v times du upon ds minus u times dv upon ds of whole divided by v square. This is u and this is v. Now put the value here. So we will have here v means s square plus 2s plus 2 whole square times du upon ds, means derivative upon ds minus 2 times s plus 1. Okay, so and this minus sign, and u is again minus 2 times s plus 1. Let me write down the curly bracket here so that it will be easy to distinguish, times dv upon ds, derivative of v. Our v is s square plus 2s plus 2 whole square, derivative with respect to s, and this whole divided by v square, means s square plus 2s plus 2 whole square and again square. Okay, this is what v, and we have to do v square means this portion again square. So this portion again square is this. Now on doing its derivative, what we will get? S square plus 2s plus 2 whole square. Square means s square plus 2s plus 2 to the power 4. 2 times 2 will get 4, and s square plus 2s plus 2 whole square times derivative of this term. So derivative of ds upon ds will get 1. So minus 2 times minus 2 will multiply, we get multiplied with 1, and derivative of 1 will get 0. This is here. Let's see here. We are doing derivative of minus 2 times s plus 1. It will get splitted it as minus 2 times derivative of ds upon ds plus derivative of 1 upon ds. So derivative of ds is 1 and minus 2 times 1 and plus 0. So we will have here minus 2. So here it is minus 2. Now minus 2 times s plus 1, put the curly bracket. We are not doing anything to this term because it is u as per the formula, and we have to find the derivative of s square plus 2s plus 2 whole square. So how we can find its derivative? I have mentioned this thing in previous formula, previous numerical also. Like we have to do this in this manner. See here, we have this term up to power s, so s square plus 2s plus 2 whole square by d s square plus 2s plus 2 will get multiplied with d upon ds times s square plus 2s plus 2. So derivative of x to the power n upon dx, derivative of x to the power n upon dx is 2 times s square plus 2s plus 2 to the power n minus 1 means 1 times, and derivative of s square is 2s plus derivative of 2 times ds upon ds will get 2. We are just multiplying each and every term with d upon ds to find derivative. So derivative of s square with respect to s is 2s, and derivative of 2s with respect to s is 2, because a derivative of s with respect to s is 1. Okay, so it will get 1, and derivative of 2 is 0. So finally we will have here, on solving this, we will get, we can take 2 common here. So 2 common, and to this 2, 4 times s square plus 2s plus 2 will get multiplied with s plus 1. So we can write derivative of s square plus 2s plus 2. Final answer will be 4 times s square plus 2s plus 2 times s plus 1. Now few more steps remaining. We can take s square plus 2s plus 2 common from both the terms. So on taking the common, we will have here s square plus 2s plus 2 is taken as common. So remaining we will have here minus 2 will get multiplied with s square plus 2s plus 2, because here it is square, so we have taken 1 as common, so 1 is remaining, and this minus will get multiplied with this minus, so it will get positive. And inside we will have here 4 times 2 will get 8 times s plus 1 whole square. S plus 1 will get multiplied with s plus 1, so s square plus 2s plus 1, and this whole divided by s square plus 2s plus 2 to the power 4. Cancel out 1, because here it will get cancelled out with this term. We will have here cube remaining, and on solving the upper, we will have here minus 2 s square minus 4s minus 4 plus 8s square plus 16s plus 8, and this whole divided by s square plus 2s plus 2 to the power 3. So on solving this, we will get 8 minus 2 to 6 s square, and plus 16 minus 4 is plus 12s plus 4 upon s square plus 2s plus 2 upon 3. You can take 2 common from here numerator, so on taking 2 common, so we will have here 3 s square plus 6s plus 2 upon s square plus 2s plus 2 to the power 3, and this is our final answer. I hope you understood these today's lecture. See you in the next lecture, and in that lecture we will learn how to do the Laplace transformation when a given function is divided by t, and when it is divided by 2 we have to do integration, and we will also learn to do integration by part in that lecture. So see you in the next video. Till then, stay safe and take care of yourself.